I hope everybody's doing well. And now that school's gonna be canceled even longer, I don't know. It's gonna be interesting to see what's gonna happen, huh, guys? But I hope you're all doing well and keeping busy and keep exercising and keep expanding your brains with schoolwork and whatever you guys are doing. I hope you're all doing well. This is going to be the beginning of chapter 6. Okay, so 6.1, and this is theorem 6.1, perpendicular bisector theorem. You've heard a little bit about bisectors. Now we're really going to get into them. This one basically, when you have the theorem in your book says, in a plane, if a point lies on a perpendicular bisector, if a point lies on a perpendicular bisector, so this line is perpendicular to A and B, okay? And bisector means it's cutting it in half. So this line right here is the perpendicular bisector cutting the AB into two equal halves. That point, if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints. It is the same distance from the endpoints of that line. So AC is going to be the same length as BC. So if CP is a perpendicular bisector of AB, then CA is equal to CB. Okay? And let's do some examples. These ones are not in your book. The ones in your book, you can watch the videos and the tutorials online, which is helpful, so I don't have to do them all. And you don't have repeats and stuff. We need to find the measure of what they're asking for. In this case, we're looking for CD. So CD. We need to find the measure of this one. Well, BD is perpendicular and it bisected AC. So AB and CB are equal. They're the same. So this point must be equidistant from the endpoints, like the theorem said. So if this is 27, CD is going to be 27. PR, we're looking here to here. Now, they didn't say that these are congruent, but we know they are congruent because SQ is perpendicular and these two are congruent. And if this point is equidistant from the endpoints, same distance from the endpoints, then these two are going to be congruent. Like that. Okay? And they want you to find PR. And PR is going to be the length. Oh, I'm sorry. I forgot to write this in here. PQ is the length 5. And if this is 5, then this is also 5. And 5 plus 5 is 10. So PR is going to equal to 10. And then the third example. Once again, perpendicular bisector, because it bisected EG into two equal parts. It's perpendicular, so this length is going to be equal to this length. So let's set those equal to each other. Now we have an equation. We can solve for x. So let's see, I'm going to subtract 3x on both sides. I get negative x equals negative 8. And if you multiply those both by -1, that's just the same as x equals 8. Oh, well, that's not the answer. My bad. That just gives us x. We're looking for GH. So GH is right here. Plug in your x. All right? So now you get 3 times 8 minus 8. That's going to be 24 minus 8, which is 16. 16 is your answer. Okay, good luck with that. And I'll get ready for the next theorem.